Hi Chemistry, we're going to finish up Le Chatelier's principle today. I hope it's going well. I find it fairly interesting, and it's a little bit of a break from the math that is coming back. So let's talk about what happens when we change volume and pressure, how an equilibrium system can respond. So Le Chatelier's principle allows us to predict shifts in equilibrium when the volume of the container containing the system changes. But what we have to keep in mind is that increasing container volume decreases the pressure. I hope that makes sense. That's from Chem 20. All right. If you squeeze the container, so decrease its volume, the pressure will increase. Okay. Now here's what you have to know. You don't have to know this, but this is the rationale of what's coming. So an equilibrium system can't affect volume. There's nothing that particles of gas can do to make the walls of the container shrink or expand, except under extreme circumstances that we're not going to deal with. What they can do is affect pressure. Okay, so I'm going to dive right into an example where we're going to cover what we've already done and then get to the new stuff. So I'm ready to go with this equilibrium system. We've seen it a lot. Formation of water vapor. Let's just rapid fire through A and B because we've already seen it before. The shift in equilibrium position, so that's left or right towards reactants or towards products. The shift when O2 is removed. So if we take some of this out, the system responds to bring some of it back. Okay, the only way it can bring back oxygen is by making water react with itself. Okay, so two waters get together to form these guys. So H2 is going to go up, water is going to go down. That's a shift left. Okay, and whenever you remove something, equilibrium shifts to the side of whatever you removed, okay, to replace what you took out. Part B, if the temperature is increased, in order to answer a temperature change question, you have to identify if it's exothermic or endothermic. So this is exothermic, which means temperature, there's energy as a product. Okay, if we increase the energy, that thermal energy with temperature, the system responds to get rid of it. Okay, so an increase in something always causes the equilibrium to shift to the other side. Okay, so to get rid of some of this energy, it'll get rid of some of this water and produce more of this stuff. This will also be a shift left. Okay, let's get to the new stuff. What happens if the volume of the container is increased? Okay, so maybe this is taking place in a syringe and we open the plunger to give it more room to breathe. All right. If you increase the volume, that decreases pressure. Okay. The system responds to increase pressure because it can't directly affect volume. It can't just decrease the volume of the container, but it can affect pressure. All right. So we lowered the pressure. When we increased the volume, we did this. Okay. This is the change to the system. Now we'll talk about the shift. The shift will be to increase the pressure. Okay. Let's look at our system. Here's what you got to do to figure it out. What matters is how many moles of gas are on each side of the equilibrium system. Okay, only look at gas because it's the only state that fills the volume. Okay, we got 3 moles of gas on the left, 2 moles of gas on the right. I'm going to write that down. 3 moles on the left, 2 moles on the right. Again, you only care about gas. More gas means more pressure. Okay, so if the system wants more pressure, it's going to shift to what side? To the left. And I'll discuss that a little bit more. Okay, so when we increase the container volume, pressure goes down. The system wants to bring some of that pressure back. More gas means more pressure, so it's going to go to the side with more gas. Okay, 3 moles on the left, 2 moles on the right. So to increase pressure, it'll shift to the side that has more moles of gas.